Okay, we're going to work on hydroboration-oxidation of an alkene. So we have our generic formula right here, our alkene, and we have 3 because we will yield 3 products of it. Now this mechanism has 2 steps. This is the first one, this is the second one. Now, the way we find borane in nature is B2H6. So an effective way of separating and getting the BH3 is using tetrahydrofuran. So that's the only reason that you use tetrahydrofuran. You will not see it in the mechanism though. So you have your alkene. Some pointers to remember. This mechanism is really long, but you should be able to do it. It's really easy, it's just really repetitive. It goes over and over and over again. That's why you have 3 of each one. So, let's see how it works. From your alkene, you should expect an alcohol. Now, the beauty of the mechanism though, is that you will get a primary alcohol, or you will get the alcohol, anti-Markovnikov alcohol, meaning the one that doesn't add to the position that favors the more stable carbocation. So we have our alkene right here, and we have BH3. BH3 has an empty orbital, and it's going to serve as an electrophile. So the double bond is going to attack it. It's going to attack the empty orbital right here, and the hydride is going to go to this carbon right here. The reason why the BH2 you expect it to have in the primary position instead of the secondary is because while you add this hydride, while that bond is forming, you will get your carbon as partially positive. As if you get it on this one, and the bond is forming, you will also get it partially positive. And if we treat the partial charges as carbocations, we can say the secondary carbocation is more stable than primary carbocation. Of course, they're not fully positive charges, but that's how you should treat it. So it's going to attach to the secondary easier than the primary. So you expect this as your product. Then you grab your product and you put it right here. This is my product, BH2, and my alkane, my chain. And then you grab the second one of these guys and you do the same exact thing. The hydride comes to the secondary because of this, and your double bond is going to attack the empty orbital right here. So then you get this again. The boron only has 1 hydrogen now, and you have 2 chains attached to it, but it still has the empty orbital. So it can be attacked one more time. So you see the nucleophile is going to attack the empty orbital right here. For mechanism purpose, you do not need to draw the empty orbital, but I'm just exemplifying it here. And the hydride is going to migrate to the secondary carbon again. So at the end of this step, of step 1, you will have 3 of these molecules attached to the boron, and you will have them like this. The R and the CH2s, you will not have double bonds anymore, because remember the hydride migrated and the double bond was broken to attack the boron. So I'm going to show you the next step. Okay, we have our second part of the reaction. So we're going to add the base, sodium hydroxide, and hydrogen peroxide in an aqueous solution, and our product is going to be this. So this is going to act as a nucleophile is going to come again to the empty orbital of boron. I'm sure you will not forget boron has an empty orbital. So it will attack the empty orbital of boron, and then we will see this. You have the same group, the same three groups attached to boron, and then you have the OH, which is this. We just attach that part, that's it. Then the second step is going to be the carbon-boron bond is going to attack the oxygen, and OH is going to leave. So what we get is the chain, this chain right here, it's no longer attached directly to the boron, it's actually now attached to the oxygen that is attached to the boron. So what do? We left the empty orbital again. So let's see what we can do with it. We come here, we know empty orbital. It's going to be attacked by the same molecule. This is where the repetitive part comes into play. We do the same exact thing, only that now this is not the same as that. So we attack the empty orbital and we just attach it right here, OOH. And then the same thing, the carbon-boron bond is going to attack the oxygen and the OH is going to leave, and we get the same thing. The chain is going to be bonded to the oxygen, which is going to be bonded by the boron, and we have two now. And we just have an empty orbital again. So, for the third time, we're going to do the same thing, empty orbital right here. The OOH is going to attack it, it's going to act as a nucleophile. And then we're just going to attach it right here, OOH on the bottom. We have our groups. And then the carbon-boron bond is going to attack the oxygen, and the OH is going to leave, and we are left with this molecule where we have the boron in the middle, and then oxygens, 3 oxygens attached to it, and on each oxygen we have our chain that we started as an alkene on the step before. So this is the molecule we're going to work with now. Let me show you the next step. Okay, so we were left with this molecule. I did fill the whole board, I guess, but don't be scared. Just run through it little by little. So we're going to react the molecule we were left with OH minus. So OH minus is going to attack, going to serve as a nucleophile. It's going to attack that empty orbital right there. And we just attach it. So we have the molecule, this one, plus the OH right here. So what's going to happen next is that this molecule, whichever one of the 3, is going to break in the oxygen part. The oxygen-boron bond is going to break, and oxygen is going to take the electrons, and we will get this. We will get our chain with O minus at the end, because formal charge, and we will get our molecule. Again, we left the empty orbital right here. There's an empty orbital. We only have 3 things attached to it, and one of them is the OH that we added, and then the other 2 are the molecules as we see them in the first step. So the O minus is going to attack the hydrogen in the OH group that we added here. And then the electrons in the bond are going to go to oxygen. And we will get this, our molecule to the boron, and then another molecule, and then we get O without the H, formal charge negative. So these are formal charges. And we have an OH, primary alcohol, and that is our molecule that we are going for. So that's the first molecule we're synthesizing. Now this is pretty much the same step, only that instead of having this molecule, you're going to have an O- that you saw from that last step. So the O-, you have your two molecules, you attack the empty orbital that you left again with OH, so you just attach the OH, then you know that the boron-oxygen bond is going to break in one of the molecules, and the whole molecule is going to leave. You're going to see it here with formal charge minus. After it leaves, then the oxygen is going to attack the hydrogen, and the bonds in this bond are going to go back to oxygen. Then you expect the oxygen to get a formal charge negative, because it only has one bond. You have another negative, so you get the second alcohol, and this is what you have. So you copy that into here. You have your molecule right here. You have two oxygens that they left, the big molecules left, and you have one more to go. So you know this has an empty orbital again, and then it's taken by OH as a nucleophile. So you just attach the OH, and then you see here the bond between oxygen and boron. The electrons go to oxygen. So this whole part leaves with a negative formal charge, and then that oxygen is going to pick up the hydrogen. The bonding electrons there are going to go to the oxygen, and it's going to leave the third oxygen with formal charge negative. And then we have our third molecule of alcohol. So overall, we have the synthesis of the first one, which is right here, the synthesis of the second one, which is right here, and the synthesis of the third one, which is right here. So they are the same, and it's this one, and that's your mechanism.